Hello and welcome to today's webinar on the fundamentals of parallel positioning systems. I want to thank you for attending today. Here at Preferred, we feel that education is extremely important to the success of any project. But before we get started, allow me to introduce myself. I'm Steve Pelt, the VP of Business Development for Preferred Utilities. I live in Tulsa, Oklahoma, and received my bachelor's degree in electronics engineering from Oklahoma State University a few years back. Most recently, I spent 23 years with FireEye. Most of those years, I was the national sales manager for the North and South America territories. I came to Preferred a little over a year ago. Since then, I have been working to expand our presence across the United States. Training will be a large part of our expanded reach. We are planning on conducting hands-on remote training in different cities across the country. Please watch for those. Today, we will be concentrating on how parallel positioning systems actually came into existence and why they are so popular today. I actually started working with parallel positioning systems a bit over 20 years ago. As with any electronic controls, they've continued to advance and become more affordable and reliable. All manufacturers have also concentrated on making these systems more user-friendly. Knowing the basics of how these systems are put together and installed can make a huge difference in the reliability and effectiveness once commissioned. I do have one request. In order to get through the material today, I need each of you to hold your questions till the end, or you can make note of those, type those in chat, or email me, and I will make sure that I address them. I want to make sure that any questions that you have, I get answers back to you on anything that I cover today. So let's get started with a brief overview of Preferred Utilities manufacturing. Preferred is a family-owned business that's been in business for over 100 years. The business actually started in fuel oil equipment and has grown from then. Preferred is made up of 4 divisions. Our Preferred Instruments, which is the burner and boiler controls, which are designed and manufactured up in our Danbury facility, as well as Preferred Utilities, which is the fuel oil handling systems. Preferred Combustion Systems consists of our burners and atomizers. Then we have Preferred Engineering. It's our nuclear outage support division, and they design, build, and support those products for that industry. Preferred has over 26 engineers on staff, and we develop our own electronics right there in Danbury, Connecticut. So we basically are a very multifaceted company that can quite honestly tackle just any project you can possibly think of. And so parallel positioning is a minor step for us most of the time. So why do we use these advanced burner controls? Okay, if you really think about it, advanced burner controls are more expensive than very simplistic designs. They also require additional training, so there's a lot of a learning curve there that is required. They're also more complicated and require more install and setup time. And linkage systems have been used forever, so why would we really want to change for something that's a lot more complicated? Well, truth of the matter is, linkage systems introduce hysteresis in the air-fuel ratio control due to slop in the linkage. And even though there are many, many different types of linkage designs out there from the different burner manufacturers, it's always a compromise because of that linkage. Hysteresis can really cause a lean condition, a rich condition, or both conditions. So actually, when we're going up the firing rate, going from like low fire to high fire, we could actually be in a lean situation. And then as we start coming back down in firing rate, we could actually go rich. And that is, of course, not ideal. The whole purpose for air-fuel ratio control is to be as close to perfect as possible. And linkage, quite honestly, wears over time. And when that wears, the slop or hysteresis gets worse over time. So we don't have that perfect combustion that we really desire. And every burner has a perfect combustion point at any point across low fire to high fire. And a dual fuel linkage system will usually require a compromise in turn down on one of the fuels. In particular, if you have a gas oil type burner, the low fire point is usually dictated by where the oil will fire at low fire, not giving you that advantage of greater turn down on the gas. So the linkage really is a compromise in that type of application. And any linkage adjustment that we end up making on gas or on oil, we have to go to the secondary fuel or the other fuel to verify and see how it has affected that particular fuel ratio. So this is a very complicated and usually time-consuming method to actually be able to get both fuels in the proper area for combustion across firing rate range. So it's going to take longer to actually tune that system properly. And if it's not done, then the secondary fuel is not going to actually combust properly, and you may be in a very rich or very lean condition. So it is more time consuming. In real world efficiency, it can be a lot lower than the designed efficiency, and it can be due to the following factors. Boilers are usually modulating from high fire to low fire continuously. And there's very few boilers that are out there that just set at high fire throughout the day or throughout a production period. And so therefore, when we're modulating, we need to make sure, if we possibly can, that we're at the optimum air-fuel ratio point, regardless of where we're at in that firing rate range. And the boiler is tuned with excess air cushion with a linkage type system so that we don't go into a rich condition, which can be dangerous. So there's always that excess air actually dialed in to the air-fuel ratio with a linkage type system. Now, what also affects this air-fuel ratio can be ambient conditions. We all know that during the winter, we have colder air, combustion air, and that air is going to be more dense, more oxygen rich. However, in the summertime, when we're much warmer, we don't have that density. So we either have to do another tune up there, or again, we're going to have to make sure that we have plenty of air during the summer months so that we don't go rich. Also, when we have a linkage type system, we have to limit the actual turn down. And if we actually limit the amount of turn down for that particular burner, that boiler is going to end up cycling on and off in low load conditions. This cycling is very inefficient because we're going to have to go through many times a post-purge, which actually dumps a lot of heat, and we're going to have to go back through a pre-purge when we light that burner back on. There's many times and many applications out there where you're at a low load condition and that burner is going to be cycling on and off quite often. I've actually been into hospital applications where I saw the burner cycle on and off as many as 2 times in 5-minute period. And this is extremely inefficient. So being able to establish a really good turn down can actually prevent that type of cycling. So if we're talking about advanced boiler controls and we're talking about parallel positioning, it truly is like going from a carburetor to fuel injection. It just makes a huge difference in how we can control that combustion process. The jack shaft linkage, it is complicated. There's no doubt about it. And a lot of people, quite honestly, it takes a while for them to learn how to set this up properly. Whereas with a direct coupled servos that are actually coupled directly to the combustion air damper, where we also have a servo directly coupled to like a gas butterfly valve, we can control those much, much closer and much more precise. So which system is actually best? If we're talking about parallel positioning, we also have to consider fully metered and cross-limited systems, or both. So what's the difference there? Well, with parallel positioning, we're basically going through and we're setting up an air-fuel ratio curve based on those particular servos, if you will, or those valve positions, that air damper position. We actually establish where they're supposed to be open and how much to get a particular air-fuel ratio at different points through the firing rate range, okay? And that will repeat, because what that system will do is once we put in these points from low fire to high fire, the system will extrapolate through those points, and there could be as many as 20, 24 points from low fire to high fire, and it will follow that curve, if you will, from low fire to high fire. Parallel positioning means that those servos are going to be moving in parallel to be at those points along that curve as it moves and modulates. If one lags the other and is not where it's supposed to be versus the lead servo, which in many cases will be the air servo, then obviously we will fault out because we don't have it in the position it's supposed to be in. That feedback from those servos is coming directly from usually a position potentiometer in the servo itself. Now, that works fantastic and has for many, many years. But we also have an option with fully metered and cross-limited, and you will hear those terms. In a fully metered cross-limited system, it's going to be using servos also, but the feedback is going to be from fuel flow meters and air pressure, for instance. So we make sure that we've got those points exactly based off of that feedback. And it's going to be cross-limited so that basically nothing gets way out of ratio. And are there systems out there that can do both? Actually, Preferred Utilities builds a system that can do both. With a flip of a switch, you can go from fully metered and cross-limited to parallel positioning. And that's a huge advantage. If you lost, for instance, a flow meter, for whatever reason it was not working properly, with a flip of a switch, you could go to parallel positioning and go off of the feedback from the servos themselves. This can keep a system up and running. It's very, very critical, and it is a huge advantage. So if we're talking about single point positioning or jack shaft control, what you'll normally have is, for instance, a flame safeguard, okay? And that flame safeguard will have what we call a modulation circuit built into it, which is usually just dry contacts. Those dry contacts through the startup sequence will make sure that the mod motor is at a full open position due to a switched input. When it drives that mod motor to wide open for purge, that will be verified. Then it will then verify again through the switches, will drive that jack shaft or that mod motor to the low fire position and verify that for proper light off. So you'll have dry contacts in the flame safeguard that actually operate that mod motor. And then once we have the burner is lit off correctly, we can then release it through those dry contacts, the modulation to an external product like a pressure troll, for instance. And then we will start modulating around a set point that is set in the pressure troll. So that actuator or mod motor then will begin operating through that linkage, the gas valve and the oil proportioning valve, even though it may not be operating at that time on gas, and it will also be actuating the air damper at the same time. And that's the way so many systems operated for many, many years. Now, when we go to parallel positioning, we basically have now our servos are mounted directly on the air damper. You have servos mounted directly on the oil valve, the gas valve, and we could even be operating a variable speed drive. We could even be operating a flue gas recirculation damper. So all of those can be operated directly. In the case of our FlexFit product, which is our least expensive parallel positioning system, it can even do damper actuation control also. So we can do draft control. So we have a lot more flexibility with these new controls because we have these outputs to drive these servos, and we're not relying on some type of linkage, if you will, to operate those valves. So again, why do we use these advanced boiler controls? The answer is pretty simple. It goes back to fuel savings. That's the reason that these were actually developed and applied originally anyhow, was for fuel savings and better consistent combustion. Through that, obviously, we're going to have less emissions, which is a big deal these days and becoming a bigger deal. And that's the reason we are seeing so many of the parallel positioning systems used on smaller and smaller burners, is to absolutely reduce those emissions. And as I mentioned earlier, these types of systems will allow us to do more turn down. And that really gives us a lot more flexibility because we're going to have less on and off burner cycling. So there's our efficiency gain right there. We can actually turn it down and it's ready to go. That also gives us a lot quicker response too. So if it's setting at low fire and that's sufficient, If the load changes, it can respond much quicker than actually having to go through a start sequence where we have purge, pilot trial for ignition, main trial for ignition before we actually are able to catch the load. So there's a huge advantage there. So we've got better control. Also with these controls, we get better monitoring and better record keeping because we can actually monitor a lot more measurements, a lot more data. So that's a huge advantage also for record keeping. Also, there's less maintenance. If we're operating that burner at the most efficient point all the time, we're going to have less sooting in the boiler itself. So we're going to have less maintenance. It's going to be required. Again, keeping our efficiency good over a long length of time. And with this type of system, the air-fuel ratio adjustment can be based off of ambient conditions. In other words, can adjust itself. That's where the O2 trim that we will be talking about comes into play. It is a huge advantage when we start having seasonal changes. Also, with this type of system, we can bring a variable speed drive into the control scheme. And this is where the combustion air fan can be modulated. All of these fans have been designed or sized, if you will, to make sure that this particular burner will make rate. And that motor is going to run normally at synchronous speed, in other words, across line. So it's going to be turning at, just under 3,600 RPM, and therefore requiring that type of amperage, if you will, to do that. And then in the past, we've always just used the damper to shut that air off, but it gives us not as good a control as we could gain with a variable speed drive. And that's a huge advantage, particularly again, when we're trying to do a light off and we don't have real good tight air damper closure. This can really be a huge advantage. So many times now we're seeing VFDs added to these systems for the actual electrical power savings. So why didn't we have parallel positioning decades ago? Well, quite simply, the technology started advancing. And when technology advances, things tend to start getting less expensive. And so here's our lower cost comes into play. So where we had to spend tons of money to be able to control a burner tightly, that's changed. Those costs have come down. Obviously, in decades ago, only the largest burners would actually get a fully metered and cross-limited type system. But with parallel positioning, with the advance of technology, we were able to put them on smaller and smaller burners and gain that precise control. Another part of it is also the reliability of the components. And we can thank the automotive industry to a certain extent for this, because so much of the automobiles these days are using stepper motors, they're using servo type motors, if you will, to control different things in the automobile. So this is where a lot of this has been realized. And the reason we're doing it is fuel costs. The fuel costs have increased so much over time and will continue to increase. That's not going to be changing. And a lot of that cost increase comes because emission reduction is required. And that's also going to continue to tighten. So having a control that can absolutely maintain perfect combustion across a firing rate range is really a plus, and those emission reductions can be measured, and it's exactly what we need to acquire. Again, the technology, why do we have parallel positioning? Well, it's because of the technology. We got faster microprocessors. We got more precise A&D converters. We went from being able to control within, a couple of degrees of accuracy to down to a tenth of a degree accuracy. And that's because the A to D converters have gotten better, and that means analog to digital. We went from 8-bit to 10-bit, which gave us 1024 different independent steps. So we can then, again, get into that 0.1 degree of accuracy and repeatability. Not only that, but sensors have gotten more reliable. Whether it's a pressure sensor, whether it's the feedback potentiometer on the servo itself. There's so many of these potentiometers that the technology was just not really great, but we can think again, our automotive industry, because they use so much feedback potentiometers, that reliability had to be there. So the actual design has gotten better and better. Again, the excellent repeatability, the technology allows that. And that's what we have to have for real good, consistent combustion. The cost of all these components came down as more and more industries started using these microprocessors and better A to D converters. The cost started coming down, and so our industry could then take advantage of all of that. And the reliability, as I mentioned before, of these components has gotten better and better, again, because of the automotive industry. And the availability improved. That's a huge part of this too. So they really have helped us a bunch from that standpoint. Also, the fuel costs increase. They've continued to increase, and they fluctuate. And by them fluctuating so dramatically, it only makes sense to take advantage of the technology that's there to actually maximize our efficiency where we can. And of course, the pressures from the EPA on emissions reduction. Our industry is going to have to continue to actually reduce emissions. That's not going to change. As I mentioned before, and it's important, okay, the parallel positioning systems, they really reduce the hysteresis. And when we're reducing that hysteresis, we're going to reduce the amount of, if you will, slop in that particular operation. So that imposes inefficiencies in the fuel consumption. And quite honestly, as they wear, it's going to increase again. So by reducing this hysteresis with direct coupled servos, we allow that burner technician to set that burner operation to its closest optimum design and maximize the efficiency at all firing rates. I repeat that because that's where we really gain so much advantage by going to a parallel positioning system, by being able to really tighten up that air-fuel ratio across the firing rate range. Now, our parallel positioning systems, if you look at it, the control could be considered the brains of the system, but the servos are really the hands and feet or the heart of the system, because those servos are actually what really makes this system work. And if they're not operating properly, then that can be a huge, huge problem. And I'm going to harp on this because so many times a parallel positioning system will have reliability issues, and it can be tracked right back to how those servos were installed. I can't emphasize enough the couplings that you use, the actual mounting of that servo, those brackets. If those aren't aligned properly, that can be a huge problem. It will not be reliable. I've actually had technicians tell me over the years, well, I've changed out air servos about every 6 months. And it's like, well, why are you doing that? Something's going on. Something's not set up, properly. Something's not aligned properly. Is there a heat issue? Maybe that needs to be looked at. Is there a vibration issue here? If so, that needs to be addressed. So vibration and heat can really kill the servo quicker and shorten its life. So you need to be very aware of how they're operating. These servos are going to be applied to, obviously, the combustion air. You're going to have them on like a gas flow butterfly valve or a oil fuel metering valve, but you're also going to be applying these to possibly an FGR. And the nice thing about it is, with a system that's non-monotonic, like for FGR, we can add FGR and then we can pull back out FGR as we go up the firing rate range. So depending on that particular burner's characteristics, we have all of this capability that we couldn't possibly dream of doing with a linkage type system. We can also add a servo for even like a burner sleeve control if you have that. And there are certain burner manufacturers out there that require that. Even though it may not be moving much, it helps shape that flame. So having a parallel positioning system that can actually control all of these different types of valves, if you will, is a big deal. Also being able to control flue dampers. And we actually designed and sell a complete system for that interfaces with our parallel positioning systems. So again, we may have the control itself, maybe the brains of the system, but the hands and the feet, the heart of the system goes back to those servos. Spend the time to make sure that when you're setting up this system, that, for instance, in a full closed position, that the servo isn't being mechanically stopped, it's being electrically stopped by the internal in-stop switch. That is a mistake that's made very, very many times. Same way on the full open position. Make sure that they're not mechanically binding, that they're actually being stopped by the internal switches, okay? That's extremely important. Okay, another advantage or some of the capabilities of the parallel positioning systems these days, some have actually integrated flame safeguards. When parallel positioning was first introduced, they worked in conjunction with an external flame safeguard. So the actual flame safeguard turned over control to the parallel positioning system, which was a separate component for modulation and control of the air fuel ratio. So, but a lot of the systems these days have that flame safeguard built in, and that's a big advantage because then all of the system basically can communicate without having external wiring, and that's important. You can also have cut in and cut out control. So with a parallel positioning that has the ability to do the modulation to actually be the flame safeguard, we can then control when that burner comes on and when it's actually turned off if the load is satisfied. Also, the firing rate control. Many of the parallel positioning systems will become the load control because they will have a built-in PID controller. So there's no need for that external modulation control. It can be built in. This is a huge advantage, obviously, because if we're using the communications that's built into a lot of these remotely, the set point could be actually changed from like a building management system. So having that load control built in is a big deal. Also, safety limit inputs. If you look at many of these systems, the safety limit inputs are built into it also. O2 trim option, and we'll talk about this more later, but by being able to add O2 trim, we're going to add a feedback that can make that difference, like I said, when the ambient conditions change in the combustion air. Variable speed drive control options. Many of the parallel positioning systems offer at least one. Some have multiples, which is really good because not only being able to control the combustion air, but being able to control maybe feed water, once again, saving electrical power but usage, but also being able to better control your system. Draft control options. Some parallel positioning systems allow that also, like our flex fit control. Lead lag control options. Some have those built in. I'm going to talk about that a little bit at the end of the presentation because there are some real limitations in the lead lags systems that are built into some of these. Most users tend to prefer an external type control for lead lag operations. However, communications to building management systems, I can't think of a system out there that doesn't allow that type of communications, so that then in the boiler room they can monitor all their boilers, and it's all done through serial communications as a rule. Now, let's talk about the system components necessary to make or that make up a parallel positioning system. You're going to have a main control chassis. At that point in time, then you're going to need some type of display or some HMI. And that can be something as simple as an LCD type display, which works fine, or you may have a touch screen type HMI. It just depends on the personal preference of the end user for that. You're going to have to select servos, and those servos are going to be selected based on the amount of torque required for what valve or what operation they're performing. This is where you're going to have to go back to normally like the burner manufacturer for a recommendation there. Now, as many people have gained experience over time, they know approximately what size they need for those applications. It's always better to have a larger servo than a smaller servo because of over torque requirements sometimes. Also, parallel positioning systems that have the integrated flame safeguard are going to require that you select a flame scanner, okay? So you'll need to do that based off of the type of fuels you're going to be burning. A pressure or temperature sensor. You're going to need that whether if you're going to be using, for instance, the internal load control to control around a steam pressure, or if it's a hot water application, a temperature sensor. Or you may end up using both if you're going to go into a hot water standby, and some will allow you to be able to do that. Now, some of these systems will not even use a sensor input. They will just be set up for track modulation. And what I mean by that is some type of external control will actually control the modulation by like a 4 to 20 milliamp signal going back to this particular parallel positioning system. Now, another selection you're going to make, and most are getting these anymore, is going to be O2 trim. So at that point in time, you'll decide whether or not you need O2 trim, and we'll buy the components necessary for that. And that's going to be a sensor that's installed in the stack. A variable speed drive. If you're going to use a variable speed drive for the combustion air, which most are doing now because the reliability's gotten better, because the costs have come down to a certain extent, and they just save a ton of power. That's all there is to it. So you're going to need to select that VFD based off of the motor size, obviously, on that particular burner. And whether you want draft control or not. We're going to see more and more draft control used in the future because there's so many combustion issues that people just seem to can't get over, And so much of it goes back to the control of the draft. So you're going to see that option used more and more as we go down the road. So let's take a look and see what some of these components look like. Obviously, a standard LCD display can be used, and it's fine for commissioning. It works fine. Touchscreens have gotten more and more popular because they just give you more information at a glance. In many cases, it's faster and easier to commission a system with a touchscreen on there. So we'll see more and more use, and the price of touchscreens have come down to a certain degree also. You have to have the chassis, as I said before, so the actual brains of the system has to be selected. And again, it depends on how much control you want to incorporate. If you wanted to do, for instance, like I said before, a fully metered cross-limited type system and parallel positioning, then you'd want to select a system like the Burner Mate Universal. We got to select a UV or IR or self-check scanners. We got to select a flame scanner. We have to select our servos. We're going to have servo for each one of those valves that we're going to control. And if we want O2 trim, we're going to need to select an O2 Pro. And that's what the Burner Mate Universal that we build does. It's got the advanced flame safeguard in it. It's got complete control, combustion control built in, oxygen or O2 trim built in, draft control is built in. All you have to do is buy the end device. Feed water control, which we haven't talked about. It can do 1, 2, or 3 element, and it even incorporates a smart feed water control. So it can actually switch down to single element when necessary and when it's the best control scheme. The Burner Mate Universal or BMU, you also can select touch screens for it, and we have optional laptop configuration. Many systems out there have this kind of capability. We feel that the BMU goes beyond most of those. And to give you an idea what the advanced flame safeguard functions are, it can do a snapshot when you actually have a burner trip. And that, for instance, the BMU saves 145 status points. That really helps the technician to diagnose a problem and what's going on. And that's one of the things when you're looking at the different parallel positioning systems out there and you're selecting one, look at how it actually operates when there is a burner trip, when there is a problem. What's it recording? So, you know, with this particular system, you get that first out capability, and it's going to tell you at what firing rate, what the stacked oxygen was, what the flame signals were, and another 141 other pieces of information. So look, when you're selecting a system, look at how it's actually recording fault data. It's very, very important for a technician. And to give you this particular slide right here just gives you an idea real quick in glancing at all of the different points that this could actually be monitored separately. It's quite advanced. The nice thing about the touch screens, and I know many of you have seen these, and if you haven't, again, it's just, I wanted to show, you know, just some simple graphics right there, but you get all this information just in an overview. These can be customized, obviously, for the particular application, but you can, at a glance, see all the inputs and outputs very quickly, and and not only that, but the operating status. So a touch screen can really give you a lot of information very quickly. And you can obviously, with this touch screen, we can look at all the status of, for instance, the discrete inputs. So we can see exactly what's going on with those digital inputs on this particular device. And we can tell whether they're made or they're not, obviously, and whether they're in the recycle or non-recycle, you know, inputs. So A lot of information very quickly at a glance. Also, the analog inputs. Another screen can give us the status and where they're at on all of these analog inputs. This is a technician's dream, because instead of having to pull out a meter and interrupt a 4 to 20 or whatever, we can actually look at everything right there and it can tell us what's going on. Very, very important, very powerful screen. And of course, the alarms. Being able to record these by time and date and so forth is going to give that technician also a lot of information on what's actually been going on with that particular boiler if they're starting to have issues. And that can really help in the troubleshooting. Now, the primary reason we actually buy these controls and use these controls is because we want to make sure that across the combustion rate or firing rate range, from low fire to high fire, we would love to have that burner at the optimum point where we have zero excess air in that combustion. Now, no one does that. We always dial in some excess air. There's no question. A lot of burners like that also. But if we can have that perfect point across the firing rate range and actually record that, which is what we will be doing when we commission it, then as it modulates, it's going to make sure that the air and the fuel is dialed in exactly where it needed to be. And that's the primary function of the control. So the other advantage, as I mentioned before, is it can really improve our burner turn down. And one of the ways it can is allowing us to have separate air-fuel ratio curves for each fuel. So if we're burning, say, natural gas as our primary, there will be a nice curve that we will save in there in commissioning that system for gas. If we have standby oil, we will have a separate curve that's saved in there for oil. We could even have a separate, say, biogas curve in there. I've actually helped a customer do a curve that was chicken fat that they were actually burning. So, and we could even have a curve in there if we had a variable speed drive and we said, oh, we lost the variable speed drive, we could actually set up a curve for bypass. So having these additional inputs, if you will, or curves for different fuels or operations is a huge advantage and can keep a system up and running. Also, with the built-in PID controller, and most have this, or load control, this can give us immense advantages over external controls because it's part of that system. And one of the things we can do there, obviously, is remote set point selection with separate PID values. So that's built into many of these parallel positioning systems. Remote modulation, being able to select either local or remote modulation is a big deal. Then you could actually modulate that particular boiler or burner, if you will, from a building management system if they want to take control of that. You can also incorporate like nighttime setback. By having that internal PID controller, you could have that setback and it could sit there at a different set point, if you will, with its own PID parameters and therefore maintain a particular temperature in the boiler when you're not needing it. Thermal shock protection can be built in. When we're starting up a cold boiler, one of the things we want to make sure of is that we don't shock that vessel. So being able to modulate up slowly or not release to modulation until a particular vessel temperature or pressure is realized, that's important too and can be built into the control. Also, eliminating interval wrap is important. If we're actually setting there with a PID it can actually end up with integral wrap. In other words, overshoot the set point big time once we've gone into modulation. So this can be built into the control also. And a huge advantage is maximum modulation limit. During some times, for instance, of maybe a year, you may want to limit that particular boiler or application to say 50% modulation. I had an application where the particular end user had bought twice the boiler that he actually needed, because in the next 5 years to 8 years, they were actually going to increase the size of their plant and they were going to need more steam. But they were ramping up to 100% firing rate, coming straight on down and shutting down. So they were cycling constantly. And by being able to dial in a maximum modulation limit, we are able to limit that down to about 30 to 40%, and therefore greatly reduce the amount of cycling. And that's something that you can do with a system like this. So we talked about O2 trim briefly. By incorporating O2 trim, it's going to allow us to compensate for ambient condition changes. That's a big deal. This is the feedback or closed loop, if you will, to make sure that what we wanted for a particular air-fuel ratio, say when we set it up on one particular day, that 6 months from now, as ambient conditions change, the O2 value is stored. Not only the positions that we told the servos to be in at that particular firing rate, but we also are saving what we want that O2 sensor value to be at that particular firing rate. So this gives us the capability to adjust beyond just those positions. We're going to make sure that it gets back to what we wanted it to be as it modulates in those particular, in that firing rate range. It really is the best way of making that system work beyond parallel positioning. And it increases safety. You can set these O2 systems up so that if for some reason we start getting really low O2, something's wrong, and we could either alarm or shut down off of that. So it really does make the system safer. O2 trim is a huge, very popular option. Another popular option, variable speed drives. And we can use these to slow down the actual combustion air fan. We may have induced draft motors. We can also control those. Feed water pumps, we could control those. Flue gas recirculation blowers. So VFDs can come into play in saving power costs wherever we're running a pump or a blower. They're just a no-brainer that way. For many, many years in this industry, people would buy a variable speed drive and they would buy the ability or bypass switching, if you will, because variable speed drives had some reliability issues. That is becoming less and less of an issue as the reliability has gotten better. And that's the reason that they're being selected as an option more and more also. The payback comes in when you're applying it because of, for instance, oversized fans, or an oversized motor is used, or if you got a partially loaded boiler. So it can actually minimize damper losses. But one of the side things that I've always heard in the boiler room is the boiler operators just say, man, it's so much quieter in here. And it's just kind of a side benefit. Variable speed drives are very popular and they will save a lot of money on power. And just to put it in perspective, here's a nice chart that shows you how much better you can control, because the horsepower savings is just monstrous. So if we're really actually coming off of synchronous speed at 60 hertz and coming down to, for instance, 40 hertz, we can save about 70% of our electrical use. This is a huge deal. Now, obviously, with variable speed drives, that control and how much you can turn down that burner depends on the burner design. And again, this is where the burner manufacturer can give you some good rule of thumb where to go. Some 50 hertz will be about a minimum. Some can go down even lower than 40 hertz. It depends on that particular design. And I would encourage you to talk with the burner manufacturer when you're actually commissioning one with variable speed drive. Now, one of the things we didn't talk about, but is built into some systems, is lead lag control. Now, obviously, you want boilers running at their most efficient firing rate, but you want to sequence boilers, if you have multiples, on and off in a manner where it makes the most sense from an efficiency standpoint. So you want to eliminate the need to run those standby boilers if they're just sitting there and they're not needed. Obviously, the correct lead lag control can do that. You can also lower set points, from external type control, which would be outdoor reset. We could also lower set points for nights, weekends, or whatever. So this could be controlled by an external device. A lot of the parallel positioning systems have this type of capability built in, but you don't get the full-blown capability as you would from, for instance, a plant master control like we offer. Many times that external device is so much better, and end users like them so much better. They just work. And of course, it can come into also modulating the VFDs for feed water and circulating pumps too. So look at the lead lag or sequencing requirements in a particular boiler room, and you're probably going to be best served by an external device, like our plant-wide controller. And this is just a diagram that shows you all the capability of our PWC and what it can actually do. It just gives you a lot more flexibility, a lot more control of that particular steam plant, or a hot water plant, same thing. And the reason I threw up these diagrams, because this is the fundamentals of parallel positioning, is that you're going to be asked about this as you start applying parallel positioning systems in steam or hot water plants. And you'll just know that this option's out there, and it just gives you a lot more capability. We have been involved in these projects for many, many years and can help any of you with these. And one of the things that I wanted to bring up also, an end user will ask you, well, what's going to be the payback on this? Well, guess what? You can go to our website and you can actually download a form, and you can plug in all this information and be able to give that particular end user what the predicted fuel savings, electrical savings, the payback basically is going to be. So this is an important document that you can actually utilize, and I would encourage you to do that. You can go to our website, and you'll see the payback analysis icon down there under tools, and click on that and utilize that. In fact, go to our website and spend some time there. You'll be able to find all our literature on anything there, but not only that, but just so many different tools in our knowledge base and in our tech library. We feel that, like I said, knowledge is power, and it's going to make you more successful. And if you're successful, we're going to be successful. So just a quick review. Our boiler controls can save fuel. That's a primary need right there. They can save electricity. The graphical interfaces can make the controls easier to operate. The advanced controls actually increase the boiler safety, and that's a big deal. Boiler room information can be available outside that plant. That's where the communications come in, and sharing that information through communications to a building management system. And we can increase the plant automation, requiring less operator interface. It can be taken care of and operated more efficiently that way most of the time. That is pretty much what I have for you today. That's the fundamentals. I know we didn't get into details there, but I want you to keep an eye out on our LinkedIn page and even our website. As we start doing hands-on training, we want to make sure that if you get the opportunity to learn about our FlexFit and BMU products and how to commission those, we want to make sure that you're able to be exposed to that. Thank you all for attending today, and hopefully I'll see you soon. Okay, well, I hope everyone enjoyed that, or it was informative for you. I do have a few questions here that have been sent. One of the first questions was, how many firing rate points should be entered from low fire to high fire? Well, quite honestly, that depends on the particular burner itself. Most parallel positioning systems require a minimum of 5, but you're not really taking advantage of a parallel positioning system if you're only putting a few points in. So most burners will have a particular area that is more critical, and that's where you're able to really customize that. So most burner applications that I've been involved in, you'll see anywhere from 12 to about 20 points. And each one of those points, of course, is saving the position of each of the servos in the system for that point, and also like a variable speed drive 4 to 20 out, it'll save that value too. Also, if we have O2 trim, it'll be saving that particular O2 value. So about 12 to 20 points most of the time. Also a question here, can certain points along the firing rate range, or curve, if you will, be modified without having to adjust all the points? Yes. Most companies call that like adjust ratio. So you could actually step through the different points along the firing rate range and go in and make some adjustments, save just that particular point, and then you can exit commissioning without affecting anything else. And that's a real great advantage. Also, another question, is a computer necessary to set up a parallel positioning system? Most don't require a computer, but some do. For instance, our products can be set up through the touch screen or the actual display that's included with the system. So it's not necessary. A lot of technicians prefer to save all of their settings and upload that into their laptops. And of course, you can do that with our stuff. So anyway, that's the questions I've got right now, unless anyone else has any questions. So anyway, thank you for being on the webinar today. And as I said earlier, hope to see you soon. Take care.